Now, in the descriptive statistics, there are two measures. How do we measure the um, parameters which are there in the through descriptive statistics? So we say measures of central tendency. And the second one is measures of dispersion. So measures of central tendency are, you can say, mean, median, mode, mean, median, mode, which talk about the centrality of the data. Okay. What's the difference? What is median? Anyone? What is median?
It's the data which comes just in middle when
The middle
arranged.
value of the data is the
One.
median.
Yes.
And dispersion mode. What is mode?
Maximum occurring.
Highest frequency or the value with the highest frequency represents mode. And what the measures of dispersion? You have standard deviation, you have variance, you have covariance. Okay, so these are the measures of dispersion. It tells that how dispersed is your data. Okay, so now these things, mean, median, mode, standard deviation, variance, they describe the data. Now we're talking about, let's say, measures of central tendency. So they indicate the value near the center or the highest point, as we know. So I may not have to tell you what is the meaning of mean. I think all of you know what is mean. When is mean useful? When do you think what type of for what type of data is mean useful? Think about it. Let's say I'll show you. Let's say you have a data like this, and on the other hand you have a data like this. Maybe it's not represented. Okay, this is scenario A, this is scenario B. So, in which scenario do you think mean makes more sense?
A.
You say A. All of you give your opinion in the chat box. In which scenario? My question is, in which scenario mean makes more sense? Write in the chat box. Yukta is saying A, Karvi A, Karan Pratap, Varun is saying A. So all four of you are saying that A in using mean in A makes more sense. Why?
It is uniformly distributed on the left and right part.
You are partially right. I mean, it is not uniformly distributed, but it is symmetrically. So this is symmetric. This is a symmetric distribution. This is a non-symmetric or skewed distribution or abnormal distribution, you can say. Okay, there may be another scenarios like this. Okay, the data may also be distributed like this. So talking about mean does not make much sense over here. But if it is symmetric, if the data is distributed symmetrically, why do you think mean, talking about mean will make some sense in symmetric and not in asymmetric? So let's consider small data. We will also get to know about another fact about mean. So let's say you have data like this, scenario A and scenario B. The data points in this are like five. I'll just make it 5, 6, 5, 8, 9, 8, 6, 7, 6. Okay, like this. And on the other hand, you have data like 5, 6, 5, 8, 20, 13, 2, 1, 3. Can you find out mean of both the A and B? Can you tell me the mean of A and B? Quickly find out the mean of A and B. So A and B very close, right? Okay, A and B are very close. Now what I do is I remove one value from A and one value from B. So let's say I remove one value from A and I remove one value from B. What is the mean now for A and B? Now tell the mean of A and B. So A is 6, 6.75 and B is 5.375. Now you see there's a huge difference has come just because we have deleted one value from B. Getting it? So B is actually representing a sort of an asymmetry in the data or skewness in the data or non-uniformity. I won't say non-uniformity, it is asymmetricity in the data. So mean is not a very good indicator. Okay, while if I find standard deviation for A and B, let's say sigma A and sigma B, I find out. Can you now find out standard deviation A, standard deviation B quickly? All of you do that. You know how to do that? Let me tell you. Uh, xi minus xa bar square divided by number of observations. Okay, so find out the standard deviation. You take it n minus 1 rather because it's we are considering, let's say this is a sample. Now find out this value. It will take some 5 minutes. Do that because here is a very important lesson we are learning, which will continue for your life. How many of you are calculating standard deviation? Please raise your hand. Okay, once you have calculated, write your answer in the chat box. If you are having any problems in calculating, let me know. So Yukta is getting A as 1.407. So I'm not calculated, but I'm assuming that you have calculated correct. Let others also calculate, and I'll see if others can conquer it to your result. Others should also write their answers so that we know. See, this exercise you will have to do anyway. In exam also you need to do this exercise, so you need to be well conversant in doing all this. Okay, Shubhangi is saying 1.39. Okay, 1.401 and sigma B is 3.56. I'll give you another 2 minutes for everyone to write their answer. After that, we'll start the discussion. So we confirm that sigma A is around 1.4. Okay. Now sigma B, let's say, is 3.56. Let's assume now it is 3.56. Now tell me one thing, which is a better measure? Let's say mu A and mu B, and sigma A and sigma B. Which is a better measure of describing the distribution? In order to describe distribution, uh, for A, which is a good measure? If, or let's say if I have to compare A and B, should I be now? Tell me one thing, Shubhangi. When you calculated sigma B, did you consider 20 or did you not consider 20?
I didn't consider 20.
Huh?
I did not consider 20.
Okay, you after deleting you have
Yes, sir.
okay. So it would have been even higher. The standard deviation would have been even higher if you would have considered 20, right?
Yes, sir.
Yeah. So if you are, so that's why you see over here, mean has lesser significance as compared to standard deviation over here. So if you are comparing two different data sets over here, or if you want to describe a data set, it is mean makes more sense if it is described with the standard deviation. So variation, or you can say measure of dispersion, which is variation, yeah, standard deviation makes more sense over here. So one thing we have to be very clear that we should not only be dependent on mean. Mean can be very misleading because it may be coming out of a very non-uniform distribution or non-symmetric distribution. Although just to clarify, this is a uniform distribution. Okay, this is a normal distribution. Uniform distribution is also symmetric across the mean. This is also symmetric across the mean, perfect normal distribution. Okay, so Anyway, we will talk about the normal distribution in coming time. So we've talked about mean over here, and that's why it is very now another question is, when do we use mode and median? When do they make significance? Or when, can you answer the question? All of you think about it. In what situations median and mode will make some value or will add some value to your descriptive data?
So since median is not dependent or does not get affected by the extreme values, so I think in the case B, median would be uh,
Very
useful.
right, Shubhangi. So median is very useful in representing the data which is skewed or which is non-symmetric. Okay, because it is not affected by the uh, not affected by the outliers or the extreme values. We call them outliers. Okay, then because how it is useful, let me show you. So you see over here, this kind of, there is this kind of distribution. Okay, so uh, its mean will be somewhere here. Okay, but it will not tell that how many if I draw a median, I will get to know that it is if the mean is lying on the right side of the median, what does it mean? Can you tell me, all of you guys? If the mean lies on the right side of the median, this is mean and this is median. So if the mean is lying on the right side of the median, what does it say? Yes.
Sir, it means that most of the values in the set are greater than the value of median.
Or you can say the more values are inclined or biased toward the higher side. Okay, more values are biased towards the higher side of the data rather than the lower side of the data, and this is called negatively skewed. Negatively skewed. Skewed means smaller or tail. So tail is on the negative side. So left side be considered to be negative and right side to be the positive one. Okay. So all of you know, I am assuming all of you know how to find out median. Please raise your hand. All of those people who know how to find out median, please raise hand. So four people have said. What happened to other people? Jitendra, Karan, Karvi, Neha, Nishu, Shrija, Rahul Chaudhary, Rajiv, Ritika, Shubhangi, Varun Seni, Yukta Parikh. You don't know? Yukta knows. Okay, they have already raised their hand. Four people. So remaining people, you don't know how to find a median. Do you want me to tell you?
No, sir, we know.
Okay. So you should respond in that because I may spend time unnecessarily another 10 minutes in telling that.
Yeah.
Okay. So we assume that median you know and mode. Now, when do we use mode and when, in what situation mode will be useful? Anyone? Actually, mode is not a very useful term, except a very useful measure, except that if you have nominal data or categorical data, only in those cases mode and median can be used to describe the data. Okay, so median and mode are mostly useful in those cases. where you have nominal or ordinal data. There you can think that okay, they have greater use as compared to mean. Okay, now um, we've already talked about many things, standard deviation. There's also a term coefficient of variation, but then okay, it probably not going to be used or the quartiles. So I'll send you these slides, but although these will not be very useful, so I am just skipping through them. Mainly standard deviation and the variance is what we will be using in the remaining part of the course. So I'm not considering quartiles and all. Uh, Also, there's a term called skewness and kurtosis. Let me just quickly run through that. Skewness and kurtosis. See, actually, if you got a symmetrical curve like this, we say it's a normal distribution curve. Okay. So if it is uh, like this, we say it's negatively skewed. If it is like this over here, we say it is positively skewed. That means tail is on the positive side, it is positively skewed. If it is tail is on the left side, it is say we say it's a negatively skewed distribution. And kurtosis means that there is a value called kurtosis, and for a perfect normal distribution, kurtosis is equal to 3. For a perfect normal distribution where mean, median, and mode are equal. Anyway, have you people read about normal distribution earlier in any of your earlier classes?
Yes, sir.
Yes, sir.
So, what do you know about normal distribution? Tell me, Shubhangi.
Um, Sir, so basically it has a function associated with it, and this graph. It works with mean and standard deviation.
Okay.
Right. Mathematically, like I know.
Have you used the table also? Normal distribution table.
Yes, sir.
Huh?
Yes, sir.
Sorry, I'm not getting you. Yes or no?
Yes, sir.
Okay, okay. Yes, you have used. Okay, so for a perfect normal distribution, kurtosis is 3. If kurtosis is greater than 3, it is like this. We say it is leptokurtic. Leptokurtic. And if it is lesser than 3, it is platykurtic. Platykurtic. So plateau, from plateau it's coming platykurtic, and leptokurtic means above 3. Okay, so kurtosis indicates the height of the curve. So the higher is the height of the curve, lesser will be the standard deviation. It will be more closer. All the values will be closer to each other. Okay, so we go ahead now. Uh, so now we go to another part where we, let's say I take a refresher of your normal distribution. So a normal distribution curve, function for normal distribution curve or fx value is, can you tell me what is that? Anyone? Anyway, I'll sigma root 2 pi e raised to power minus half x minus mu by sigma whole square. Okay, so these are the parameters. So parameters for a normal distribution curve are mean and sigma, mu and sigma, And perfect normal distribution is symmetric across the mean. It never touches x-axis. It is asymptotic to x-axis. Okay. Now, if I ask you that, can we find out probability? Okay, let's see what is this curve actually. Where are we getting this curve from? Let's see that first. Some basics. How do I get this curve? Can you tell me what is there on x-axis and what is there on y-axis? What is there on x-axis? Obviously, we have x over here on the x-axis. And what is there on the y-axis? Yes, anyone?
Sir, it is f of x, the function, probability density function.
F of x. Okay, you are saying it is f of x. That means if I draw one line of x over here and I move it across, I will get the value of fx. Can I get the value of fx? Yes, tell me. Is it possible for me to find out the value of fx? Let's say we are talking about mean height only. It is something which you all connect to. So we're talking about height is 165 centimeters of a group of people, and standard deviation is, let's say, 5 centimeters is the standard deviation. Can I find out fx? Big question over here. Yes, you must be thinking, what is there? I mean, I can just substitute, no, mean I know, standard deviation I know, and x also I can know for what value of x. What is the probability that a height is 160 centimeter? So I want to find out what is the probability when of x equal to 160. I can simply substitute 160 here, mean mu here, sigma here, and get the value of fx. Right or not? How many of you say we can? I'm also saying we can find out the value of fx. So will it be 0 or non-zero? The probability value will be 0 or non-zero? Probability value will
Non-zero.
non-zero, you are saying. How many of you are saying it will be non-zero? Please raise hand. Karan Pratap is saying non-zero. Okay. Only Karan Pratap is saying, other people are not saying anything. Yukta is saying it will be non-zero. Okay, you people are saying that. But have you ever read about point probability function or point probability value for a continuous distribution? So point probability, all of you Google and tell me what is the meaning of point probability. I will ask any one of you. Point probability value. All of you Google it. And in another 2 minutes, I'm going to be asking any one of you to explain what is the meaning of point probability value for a continuous distribution. Okay, Varun or Karan? Karan? Varun, tell me. You were about to tell me something.
Yes, sir. I'm not able to get it.
Okay, tell me one thing. How many points are there between 2 points on a number line?
Infinite.
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 So for a continuous distribution, you really can't point that this is the point. You can't really have you can't really pinpoint on a number in a continuous distribution. Are you getting? If let's say I want to put a finger on 160, I am actually not putting a finger on 160. There are infinite points. I'm actually putting a finger on infinite points, right? What is the meaning of continuous distribution? That it can take any value. Okay, the random variable x can take any value. So that means point probability value for a continuous distribution is always zero. Now you must be saying, sir, यहाँ formula में डाल के value तो निकल ही जाएगी. Yes, but that value also will also be like uh, not there. It will not be representing a single point. Getting it? So it is actually, you can mathematically it is possible to get value, but practically or uh, conceptually, point probability function value for a continuous distribution is always zero. Okay, so if I ask you, given these parameters, and what is the value of fx equal to 160, then you have to write it is equal to zero. And why? Because for point probability value for a continuous distribution is zero. Okay, you can Google it, you will find many explanations to that, but then I will not spend too much time on it. Okay, so this is first concept, which probably most of you might not have known. Now, so what can we calculate if the point probability value is zero? So what if you want to know fx equal to 60? I want to find out the value. So you can only find out value in a given interval. I want to find out probability that what is the probability that x lies between 159.9 and 160.1. I can find out this value. Okay. Now how can I find out this value? Who's going to tell? Neha? Rahul? How can I find out the value of this expression?
सर वो फॉर्मूला होता है ना फाइव दिस पॉइंट पहले 160 का निकाल लेंगे फिर 159 वाले का फाइव में रख के देन आंसर आ जाएगा
इंटीग्रल नहीं करेंगे? इंटीग्रेशन नहीं करेंगे क्या? ये लेट्स से ये मीन
और
कितना
वो
है?
इंटीग्रेशन के बाद का जो रिजल्ट आता है ना वो उसका बता रहा हूँ जैसे वो के
अच्छा,
160 से कर दो
ओके.
एक बार
So we will integrate it from 159.9 to 160.1 fx dx. Okay, this is what we are going to do. Now इसका जो इंटीग्रेशन करना है वो बड़ा मुश्किल है, इतना आसान नहीं है. अगर आप देखेंगे fx का जो द एक्सप्रेशन है, दिस एक्सप्रेशन इज नॉट इजी टू इंटीग्रेट. आपको कितनी देर लगेगी ये इंटीग्रेशन की वैल्यू निकालने में? If I ask you to find out the value of this integral, Can you guys find out the value of this integral? Yeah? Yes, Shubhangi? Karvi?
Yes, sir.
Can you find out the value of this integral?
Sir, it will take me a bit of time.
Can you give me an approximation how much time it would take?
Sir, like it will depend. I don't even remember all the way to proceed,
So
honestly speaking.
can I assume that you're going to take half an hour to 45 minutes to get this value?
Yes, sir. Most probably.
So that's what happens with most of the people. Like all of you have read it and all know. But then when the problem comes like this, you will not be able to immediately go and find out the integrals. That's not easy. So what scientists have done is that they have come up with the normal distribution table, which you already know. How many of you know normal distribution table? Anyway, I'll show you just a second. All of you download this normal distribution table. I am also exhibiting it. Now, what you see over here is a kind of a standard normal distribution. Okay. What happens in this is, let's say I have a distribution like mean equal to 50, standard deviation is equal to 2. Okay. And I have a normal distribution like this. So mean is 50. And I want to find out the area between, or the probability that the, let's say mean is representing marks. Okay, so we are talking about marks. What is the probability that a student scores between 70 to 80 marks? I want to find out what is the probability that the student scores marks between 70 to 80 marks, between 70 to 80. So I will use this table to do that. But in order to use this table, I have to convert the normal distribution into standard normal distribution. So how do I convert normal distribution to standard normal distribution is in the form of this formula, x minus mu by sigma. Okay, it is called mapping. So this is normal distribution. Okay, now it has to be mapped into a, sorry, this one. This has to be mapped into a normal distribution. Again, I'm sorry, I have to छोटा करते हैं इसको थोड़ा. Exactly like this, and not looking exactly like this. Okay. So here the mean over here will be mapped. So mean for now standard normal distribution SND. I convert it into standard normal distribution. I also map these limits on standard normal distribution curve over here. I want to find out what are these values. I want to find out what will be, if that is 70, what will be value over here. If this is 80, what will be value over here. So in order to map this, I use this function, this Z, which is called standard normal variate. Standard normal variate. Okay. So Z1, I can say this is Z1 and this is Z2. So Z1 will be X minus mu, that is X is 70 minus mu is 50 divided by sigma थोड़ा ज़्यादा लेंगे, we take it 20 for convenience only. So this Z1 will be 1 and Z2 will be 80 minus 50 by 20. So it's coming out as 1.5. Getting it? So we now look into now. Can you let me check? Can you guys find out this area quickly using the link which I've given in the chat box? I'm just checking whether you people know it or not. How many of you are calculating it? Please raise a hand. Yukta, only one person. Shubhangi. Ritika, Shrija. Okay. So calculate the value. Tell me the area. Yes. Anyone who's calculated? Point 0.091. Okay. Other people? So this is you can consider a small assignment for you to calculate this. We'll start from here only tomorrow.